In this lesson, we are solving systems of equations using the substitution method, part 2. So let's review what we covered in our previous lesson. So we had these steps to follow that we used when we were using the substitution method to solve a system of equations. And if you recall, in all of our previous examples, this first step, which says solve for one variable in one of the equations, so we had one of the equations in our system was y equals or x equals, that first step was already done for us. And so you're going to notice today that the systems that we're working with aren't going to have that first step done for us. So we are going to have to create one of the equations and convert that into y equals or x equals form. And then the rest of the steps that you did previously are the same. So let's look at our first system. If we have the system x plus 7y equals negative 25 and 5x minus 4y equals negative 8. So we can see that neither of these equations are in the form y equals or x equals, which is what it has to be in for us to use substitution. So I'm going to give you a hint here in a moment, but I'm going to guide you through this process to begin with. So if we look at each of our variables in the system, so we have our x, we have 7y, we have 5x, and we have, it's really a negative 4y. So we're focusing on this coefficient of our variable, which will help us determine which one of the variables it will be the easiest to solve for. We don't want to make this any harder than it needs to be, so we might as well find the simplest way to do this. So if you notice that our coefficient of x in this first equation would be a 1, our coefficient of y here is 7, our coefficient of this x is 5, and our coefficient of this y would be negative 4, but we can see that we have a value here. So my hint to you is that you always want to pick, if at all possible, you always want to pick to solve for the variable that has a coefficient already of 1. It just makes that process a little bit easier to maneuver as you continue this process. So in this case, I'm going to pick this top equation, and I want to solve that for x because my coefficient is 1. So as you're going through these examples, it's helpful to say and ask yourself, which variable am I going to solve for in which equation? How can I make this the easiest possible? So I'm going to then convert this first equation, x plus 7y equals negative 25. So I start with my equation, and just like we isolate y, we're going to isolate our x. So in order to get x by itself, we would subtract 7y from both sides. And so then we would have the equation x equals negative 7y minus 25. So now that we have our new equation in y equals or x equals, so in this case it's in x equals, I'm going to cross out that whole top line because now I don't want to be confused and use either of those equations. Now I have my 5x minus 4y equals negative 8, and I have this new converted equation. So those are the only two equations that I want to work with. So then recall from the previous lesson that once we have y equals or x equals, that we are going to take this expression, so the negative 7y minus 25, and substitute it into the other equation. So we're going to use the equation 5x minus 4y equals negative 8. And since this equation is set equal to x, then I'm going to substitute this expression into this place for my x. So when I do that, don't forget that we have our coefficient here of 5, so we are multiplying that whole expression, so both of the terms here, so that's why I have the parentheses. So 5 times negative 7y minus 25, close parentheses, minus 4y equals negative 8. So you can see that the only thing that changed from this equation to the next step was that I substituted this expression in for x. So then we distribute, so 5 times negative 7y is negative 35y, and 5 times negative 25 is negative 125, minus 4y equals negative 8. So our next step is then to combine our like terms, so negative 35y and negative 4y. So that would be negative 39y minus 125 equals negative 8. So in our efforts to isolate y, we would add 125 to both sides. And we would have negative 39y equals 117. We would divide both sides by negative 39, so y equals negative 3. So now that we have our value of y, we can take our equation, one of our two equations. I always try to pick the one that looks the easiest to make it easy on ourselves. So I'm going to use the x equals negative 7y minus 25 equation. And using my value here for y of negative 3, I'm going to substitute that into this equation in for y. So I would have x equals negative 7 times negative 3 minus 25. So negative 7 times negative 3 is positive 21. And 21 minus 25 would give us an x value of negative 4. So our ordered pair would be negative 4, negative 3. So in this lesson, we are just working on completing that first step in converting one of the equations into y equals or x equals form. So what I want you to do now is to pause the video and work out these practice problems. When you are finished, push play to check your answers. So there are three systems here that you can see that none of the systems have an equation that's already in the form x equals or y equals. So you are going to have to choose which variable to solve for and in which equation. So remember my hint that I gave you that if at all possible, you want to solve for the variable that already has a coefficient of 1. So hopefully, as a guide for this first one, you can see that your coefficient here is negative 6. A coefficient here is a positive 6. Coefficient here is 4, and our coefficient of y is 1. So this should be your goal, is to solve for this y in that second equation. Hopefully that will help you get started. When you're finished with these three equations and solving those systems, then push play to check how you did. All right, hopefully you have finished those three systems and solved those using substitution. So the solutions are on the screen for you. So the first system, the solution is negative 4, negative 9. In the second system, the solution is negative 7, 6. And in the last system, the solution is 5, negative 5.